All right, in this section, I want us to look, we're going to cover um, transformations of functions. And I want us to take a brief look at the different types of graphs that we're going to cover. But I also want you to study the parent function, meaning what is the original equation to a linear function, a quadratic function. So I want you to take a look at our first example. We have a linear function, and it's noted that the highest power over the x variable is 1. Notice that I've given you an example and then what the graph looks like. So I want you to study and understand the parent function is this f of x is equal to y. And remember that f of x equals to y is the same thing as saying y is equal to x, where if I wanted to talk, instead of making this a linear function, this is a linear equation. And then that we're adding numbers uh, to the left of our x and right next to our x, but the highest degree to the variable x is 1. Quadratic. A quadratic function, the highest power over the x variable is 2. Here's the parent function. F of x is equal to x squared. That's the original um, start of the function. And then you will know when it's quadratic because the highest power is 2. A cubic function. The highest power over the variable x is 3. Look at the shape of the graph where the higher the power, it starts to curve. We have our parent function f of x is equal to x cubed. And remember the highest power is 3. Then we have the square root function. The x variable is square rooted, meaning the x variable is under the square root symbol. So we have a square root equation. The parent function is f of x is equal to negative x, excuse me, f of x is equal to the square root of x. And look at the graph of a radical function, square root function. Then we have the absolute value function, absolute value equation. We have a V-shaped graph. The x variable is within the absolute value signs. Here's the parent function f of x is equal to the absolute value of x. Now we'll probably see the latter three later on in the semester, but we have a rational function, and this is where the x variable is in the denominator. It's in the denominator, and we have to set a restriction. Remember, we cannot have 0 in the denominator. We can have any other number except 0 in the except 0 in the denominator because it would make the um, expression or our rational function undefined. We have a logarithmic function. The log of x variable is taken. So here's our parent function f of x is equal to log of x. And then we have our exponential function. The x variable is an exponent above the number. Here's our parent function here. Y is equal to a to the x power. And we see what the graph looks like. So we'll, like I said, the latter three we'll talk about later um, on in the semester, and it makes much more sense. But definitely this first page, well with all of the functions, become familiar with them. But the first page, we've seen all five types of graphs um, so far.